I will take three more special formulae of integration, which is very helpful in avoiding the substitution. Each and every time taking the substitution, differentiating, then what? Integrating, then getting back to the original variable is very time consuming one. That's why some special formula, just like x plus ax plus b is there, and the three more formula I will take. These are all really very useful in CET as well as in theory examination. But you have to code this formula. If you have used this formula, you have to code that particular formula, okay, in the examination. So first one is integration of f of x whole raised to n. F of x is any equation in x, okay. Any function means any equation in x. F of x whole raised to n, as usual, n is any real number except minus 1, okay. In differentiation, x raised to n should not be equals to 0, or f of x raised to n should not be equals to 0 in differentiation, but in integration, n should not be equals to minus 1. Otherwise, n is any real number. N may be any real number except minus 1 integration. And differentiation in x raised to n or f of x raised to n should not be equals to 0, and n may be any other real number except 0. F of x whole raised to n into f dash of x. What do you mean by f dash of x? Differentiation of this f of x dx. If the given integrand exactly matches with this form, then the answer is, the integral is, answer is integral. It is integrand, it is integral, answer is integral. X is called variable of integration. The process of getting the integral for a given integrand is called integration. F of x whole raised to n plus 1 upon n plus 1 plus c. The answer is f of x whole raised to n plus 1 upon n plus 1 plus c, first one. And second one is, if the integrand is exactly in this form, straight away I can write the answer like this, okay. Second one is integration of f dash of x upon f of x only, not f of x raised to n dx. That's equals to numerator is the differential numerator in the differential coefficient of denominator. Then the answer is log f of x. I told you for log you should put modulus. Log f of x plus c. Third one, integration of f dash of x upon root f of x. F dash of x upon root f of x is equals to 2 root f of x. It is equals to 2 root f of x plus c, okay. So these are all the three formulae. You have to remember just to avoid the substitution. For example, look here. For example, we will just give an example to understand all these formulas. For example, first one, integration of sin raised to 6x into cos x dx. Sin raised to 6x into cos x. Now, I can write it as it is sin x raised to 6 into cos x dx. Now here, f of x is what? Sin x. What is the differentiation of f of x? F dash of x. Cos x exactly in the form of f of x raised to n into f dash of x. F of x raised to n into f dash of x. The answer is f of x raised to n plus 1. F of x is sin x here. Sin x raised to 6 plus 1 upon 6 plus 1. So simple. So that's equals to, it is in the form of integration of f of x raised to n into f dash of x dx is equals to f of x raised to n plus 1 upon n plus 1. F of x whole raised to n plus 1 upon n plus 1. That formula is applicable here. F of x is sin x exactly in this form. It is the given integrand is exactly in this form. F of x is sin x. F of x raised to n into f dash of x. Sin x differentiation itself is cos x. N is 6. Therefore, the answer is f of x with sin x. F of x is sin x here. 1 raised to 6 plus 1 upon 6 plus 1 plus c. That's equals to sin x raised to 7 is sin raised to 7x upon 7 plus c. Second one, integration of tan x dx. We know that tan x dx integration is it is log sec x or minus log cos x. Both the formulas were given in the beginning, but let us prove it. So it is equals to by this formula. It is equals to integration of tan x is sin x by cos x. Now what is the cos x differentiation? Cos x differentiation is minus sin x. Cos x differentiation is minus sin x, but in the numerator only sin x is there. Therefore, I will take one adjustment on the minus. I will write minus of minus. Okay, I have taken like this. Minus of minus sin x. Minus into minus is plus sin x. Now exactly it is in the form of f dash of x upon f of x, is it not? Cos x is f of x here. Its differentiation is f dash of x is minus sin x. Therefore exactly in the form of second one, f dash of x upon f of x dx. That's equals to log of mod f of x. F of x is what? Cos x. Therefore the answer is minus log of cos x. Is it not? I have given both the formulas. D by dx of the integration of tan x is minus the log cos x as well as it is log sec x. How it is log sec x? This minus is taken to the power of cos x. No, it is cos x raised to minus 1. M log n is log m raised to n. M is minus 1 here. Therefore, n is minus 1. N log m is log m raised to n. Means log cos x raised to minus 1. What is the cos x raised to minus 1? 1 by cos x. A raised to minus 1 is 1 by. 1 by cos x is sec x. So, how do we do? This is answer. This answer is also okay. So, here f of x is cos x. Therefore, f dash of x is what? F dash of x is cos x differentiation minus sin x. Because, you quote this formula, because this minus as it is in the form of f dash of x upon f of x. Integration of f dash of x upon f of x. Exactly this given integrand is in this form. F of x is cos x. The differentiation is minus sin x. Means f dash of x is minus sin x. If it is in the form of f dash of x upon f of x dx. That equals to log of f of x, mod f of x. In front of log, in the final answer, you have to put mod. Okay. So, this reasoning should be given. A reasoning ಬೇಕಾಗುತ್ತೆ. ಇವತ್ತು ಮಾರ್ಕ್ ಕಟ್ ಮಾಡಬೇಕು. CET ಗೆ ಬೇಕಾಗುತ್ತೆ. theory why that is the integral is written with which formula is to be quoted here. Third one, integration of f dash of x. ಇದೆಲ್ಲ ಫಾರ್ಮುಲಾ ಮಾಡ್ಕೊಳ್ಳೇಬೇಕು. ನಮಗೆ ಇಂಟಿಗ್ರೇಷನ್ CET JEE ನಲ್ಲ ಒಂದು too many questions are will be there in CET and as well as JEE. Integration of f dash of x upon root f of x is ಏನಂತ ಹೇಳಿದ್ರೆ 2 root f of x ಅಂತ ಹೇಳ್ತಾರೆ. It is 2 root f of x. So, for example, integration of it is 2x plus 3 divided by root of x square plus 3x. Exactly formula. There is proof and avashyakate. Proof this one is not necessary. You can tell that this is not given in the textbook. But you should remember these three formulas and how to quote that formula whenever that formula is used. Okay. So, time it is now f of x is what? X square plus 3x. What is the differentiation of it? F dash of x square differentiation is 2x, plus 3x differentiation is 3. Therefore, it is exactly in the form of f dash of x upon root f of x. That's equals to 2 root f of x. It is nothing but a special, in particular case of first one. Okay, f of x, we take it to the numerator. Root f of x is f of x raised to minus half. Therefore, answer is f of x raised to minus half plus 1. That's equals to half, means square root, upon minus half plus 1. That's equals to half. 1 by 2 is multiplied. Division is converted to multiplication. 1 by 2. Reciprocal is 2 by 1. Root f of x. It is nothing but a particular case of the formula 1 only. Let it be. It is. Therefore, the answer is 2 root f of x. What is the f of x here? X square plus 3x. Because you quote this formula. Because it is in the form of f dash of x upon root f of x. Instead of taking to the numerator raised to minus half, so one step can be avoided. We can save 1 or 2 steps by putting this formula directly in. Otherwise, this is actually as good as this first formula only. Root f of x is taken to the numerator to become f of x raised to minus half into f dash of x. 1 upon root f of x. 1 upon root a is equals to a raised to minus half. Therefore, it will become f of x raised to minus half into f dash of x. N is minus half. The answer is f of x raised to minus half plus 1. That is half. F of x raised to half is square root of f of x into half plus 1 minus half plus 1. 1 by 2. 1 by 2 is in the denominator is multiplied. That is 2 by 1. Therefore 2. So first case only, but no need to take root f of x to the numerator. If this formula is quoted directly, you can write down the answer. Okay. So because you write down the reason for this answer. Because integration of f dash of x upon root f of x dx is equals to 2 root f of x. I will take the proof of this one. Okay, I will take the proof of these three. Actually, for the examination, those proofs are not necessary. Try to learn, apply these formulas. Okay, ಈ ಮೂರು ಫಾರ್ಮುಲಾ ಹಚ್ಚೋದು ಕಂಪಲ್ಸರಿ ಕಲ್ತ್ಕೊಳ್ಳೇಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಇಲ್ಲ each and every time substitution is time consuming one. So proof of that, I will take the proof. Only proof of one I will take. Integration of first one. Not necessary for the examination. Not necessary. Not necessary for example. But formula is necessary. Formula, application of formula is very must, but proof of this formula is not necessary. Let us prove it by substitution. By substitution, let us prove it. Let us take t is equals to f of x. T is equals to f of x. I told one part is f of x and another part is f dash of x. Then you have to take t is equals to f of x. Okay, differentiating with respect to x. dt by dx is equals to d by dx of f of x. What is the d by dx of f of x? It is f dash of x. Therefore, dt by dx is equals to f dash of x. dt by dx is equals to f dash of x. Therefore, dt upon f dash of x is equals to dx. I'm sorry. dt is equals to f dash of x dx. d by dx of f of x is f dash of x. Differentiating with respect to x means you have to take d by dx on both sides. Therefore, here it is dt by dx, here d by dx of f of x. Okay, dx is cross multiplied. Therefore, look here, f dash of x dx is dt, f of x is t. Therefore, it is exactly in the form of integration of t raised to n dt. This is t, no? T raised to n. Then f dash of x dx is dt. Therefore, this is t raised to n, this whole is dt. Now what is the integration of t raised to n? T raised to n plus 1 upon n plus 1 plus c. So t, just substitute for t. T is f of x. F of x raised to n plus 1 upon n plus 1 plus. That's the answer. Okay. Second one is also same. Take f of x is t. Okay. Same substitution. For second one proof. Integration of f dash of x upon f of x dx. Take the same substitution. Is f of x. I don't know. That is the substitution technique. Whenever you are taking the substitution, in the majority of the case, one part is f of x, another part of the integrand is f dash of x. Take t is equal to f of x. Two factors there. One factor in a differentiation, two factors are there. One factor is the differentiation of another factor. Then take t is equal to f of x. On the f of x, on the f dash of x, the integration only. I got t by f of x and it won't write. T is equal to f of x straight away by differentiating etc. The same process. Therefore dt is equal to f dash of x dx. We know one shortcut. This two step on a while one. I will tell you one shortcut. While converting dx into dt. What is that technique? ಇಲ್ಲಿ t differentiating ಅಷ್ಟೇ ಹಾಕೋದು not with respect to x. t ಕಡೆ dt ಬರ್ಬೋದು. x ಇದ್ದ ಕಡೆ wherever the t is there you put dt. And wherever f of x is there, right, f dash of x dx. That's all. F dash of x. For example, t is equal to sin x substitution to them. Differentiating with respect to x ಅಂತ ಬರೆಯೋದು. Then dt is equal to sin x differentiation cos x dx. ಒಂದೇ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಕೆಲಸ ಆಗುತ್ತೆ. x is greater dx along with the formula of differentiation dx. And t is greater dt. ಎಲ್ಲ ಒಂದೇ one step ಅಲ್ಲಿ differentiating with respect to x ಅಂತ ಬರೆಯೋದು. dt by dx is equal to sin x differentiation cos x dx ಅನ್ನು ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋದು. ಎಲ್ಲ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಇಷ್ಟು ಸ್ಟೆಪ್ ಒಂದೇ ಲೈನ್ ಅಲ್ಲಿ ಬರೆಯೋದು. Differentiating and t is the dt ಹಾಕೊಂಡೆ f of x differentiation is f dash of x the sine of x dx is to be taken along with the differentiation formula. F of x differentiation is f dash of x. Along with that one dx is to be taken in the sine of x. T is equal to dt. For example, t is equal to tan inverse x. Then dt is equal to tan inverse x differentiation 1 upon 1 plus x square. Along with the formula of integration dx, because dt by dx one ಬರುತ್ತಾ dx ಈ ಕಡೆ ಬಂತು. Differentiating with respect to x ಮಾಡಬಾರ್ದು. t is equal to tan inverse x. Differentiating with respect to x. dt upon dx is equal to tan inverse x. dx ಆ ಕಡೆ ತಗೊಂಡು ಬಂದೆ. Therefore dt is equal to tan inverse x dx. ಅಲ್ವಾ? Instead of cross multiplying etc. In simple one step you can say the side of t you take dt. In the side of x take the differentiation formula of that function and 1 dx. First time, therefore t is f of x. T side dt ಬರ್ಕೊಂಡೆ f of x differentiation f dash of x in the side of x dx. Therefore it is equal to f dash of x dx is equal to dt. It is integration of dt. This whole is dt upon t. What is that dt by t? Whole is dt by t log t mod in front of log you have to put mod. Okay, that's equals to log of what is the t? T is equals to mod f of x. No, t is equals to f of x plus c. Third one is also same. I'm not repeating it. Third one, integration of f dash of x upon f of x. T is, take t is equals to f of x. Differentiating t sin dt, f of x differentiation is f dash of x, x sin dx. X is the dx, t is the dt, but f of x is to be differentiated. F of x differentiation is f dash of x. Therefore, it is integration of f dash of x dx is dt divided by root of t. Everything, one substitution is taken everywhere in place of old variable, new variable is to be taken. Okay. That's equals to integration of root t is t raised to half minus half. Root t is t raised to half, taken to the numerator, t raised to minus half dt. Part integration of part bhada sulabha. 1 by root t. When substitution is taken, so variable of integration is here x, and the new variable is t. Everything should be converted to t. Now t raised to minus half. 1 by root 2 is root t. Root means square root of t, means t raised to half. 1 upon t raised to half is taken to the numerator. It is t raised to minus half. To the t raised to minus half integration. It is t raised to minus half plus 1 upon minus half plus 1. Minus half plus 1 is half. It is 2 t raised to half upon half. This half is cross multiplied. Is multiplied, not cross multiplied, multiplied. A upon b divided by a upon b by c is there. Denominator b by c. Then a into c by b. Therefore, denominator is 1 by 2. It is multiplied 2 by 1. Therefore, 2 by 1 is 2. B by c will be c by b. 1 by 2 becomes 2 by 1. 2 by 1 means 2. 2 into t raised to half is root t. Just get substitute for t. That's equal to 2 into root t is f of x. T is f of x. Finally, when substitution is taken, you have to get back to the original variable. Now let us take some problem. But let us solve some problems using this formula. But exactly, it will not be in the form of f dash of the given integrand may not matches with exactly these formulas, but some manipulations are to be taken. ಸ್ವಲ್ಪ manipulation ಮಾಡಿಬಿಟ್ಟು, so there may be a constant difference. Variable difference cannot be adjusted, but constant difference is there. Second example I have taken integration of tan x that's equal to sin by cos x, tan is sin by cos. Actually cos x differentiation is minus sin x. Only sin x is there. A shortage of minus, a constant minus 1. So that minus 1 is multiplied. No, minus of minus sin x is taken. Such manipulation you have to do. Then it will be in the form of f dash. Any one of these three forms. Exactly ಆ ಫಾರ್ಮಲ್ಲಿ ಇರಲಿಕ್ಕಿಲ್ಲ, ಇದ್ರೂ ಇಲ್ಲ ಅಂತಂದರೆ ಸ್ವಲ್ಪ ಕಾನ್ಸ್ಟೆಂಟ್ ಶಾರ್ಟೇಜ್ ಇತ್ತು ಅಂದರೆ ಕಾನ್ಸ್ಟೆಂಟನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಡಿವೈಡ್ ಮಾಡಿ ಮ್ಯಾನೇಜ್ ಮಾಡ್ಕೋಬೇಕು. Then it will be reduced to these form. Then straight away take the formula. Let us take 2-3 examples on these formulas. Integrate the following. Exercise number 7.2 only. I think you got the answer for above yesterday's homework. Everything is mentioned. Substitution, everything is mentioned. Now, integrate the following with respect to x. Okay. First one is, it is one CET question. Number of times this is asked. So first one is root of tan x upon the sin x cos x. CET बहुत सारी question paper. Sin x cos x. Integrate the following with respect to x. Okay. Integrate INTE. I'm writing the spelling of integration as INTI, integration. INTE. Integrate the following with respect to x. First one is root tan x upon sin x cos x. And second one, yesterday's homework only. It is 10x raised to 9 plus 10 raised to x log x to the base e divided by x raised to 10 plus 10 raised to x. If that formula is understood, in one step you can get the answer. This is also asked for CET once or twice. Okay. And third one is 1 by x log x. Do बहुत सारे x सब लिखेगा 1 upon x log x. Okay. And fourth one is 2 cos x minus 3 sin x. 2 cos x minus 3 sin x upon 6 cos x plus 4 sin x. Fourth one. Okay. Sin x upon 1 plus cos x the whole square. Sin x upon 1 plus cos x the whole square. Next one. Sin inverse x upon root of 1 minus x square. It is 1 by cos square x, 7.1 by cos square x into 1 minus tan x the whole square. Like that. Okay. Try the remaining examples of exercise number 7.2. Okay. Almost all problems were solved. In between, some problems were left out. So okay. So you have to try the remaining. Okay. Either by direct substitution method, or for all these problems, substitution method is you can solve it by substitution method also, or you can use the formula. Just 3 formulas, no 3 formulas like that, no. So those 3 formulas can be used, or even substitution method also. Okay. Integration of root of tan x upon sin x. All those 3 formulas are based on substitution technique only. That is shortcut formulas. Shortcut formula. Sin x cos x. What I am doing here is what it is, cos x I am dividing, on cos x I am multiplying the denominator. Root tan x upon, it is sin x by cos x I am taking. Cos x is divided in the denominator. Sin x upon cos x. Upon cos x into, so cos square x. It is balancing. Cos square x upon cos x is cos x only. Cos square x upon cos x is cos x. Okay, dx. Integration of root tan x upon sin x by cos x is tan x now. Into 1 by cos square x, I will take it as 6 square x dx. Understood? Sin by cos is tan, no? And 1 by cos square x is taken as 6 square x. Understood? 1 by cos square x. So it is 1 by cos square, no? Denominator means 1 by cos square is 6 square x. What is root tan x upon tan x? Well, sorry, basics root tan x, 1 upon root tan x. I will take 6 square x dx like here. Why it is root tan x? Root a by e. ಈ ಬೇಸಿಕ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಕಲಿಸಿ ನಾನು ಸುಸ್ತಾದೆ, ಬಟ್ ಆದರೂ ಕೊನೆವರೆಗೂ ಕಲಿಯೋದಿಲ್ಲ. ರೂಟ್ ಎ ಬೈ ಎ is equals to root a upon root a into root a. 1 root a cancels. 1 by root a. That's why a and the tan x, I have taken tan x as a in mind. Root a upon a, root a, 1 by root a is root tan x. ಹೌದಾ? ಈ ಕೆಳಗಡೆ ರೂಟ್ tan x ಹೋಗುತ್ತೆ upon root a. A means tan x. That's equals to exactly in which form it is. What form it is? It is f dash of x dx upon root f of x. Here it is f of x is tan x. F dash of x is, therefore, f dash of x is tan x differentiation to what? F dash of x means differentiation of f of x. What is the differentiation of tan x? 6 square x. F of x is tan x. F of x is x square. F dash of x means differentiation of f of x is f dash of x. X square differentiation 2x. Okay, f dash of x is 2x. F of x is tan x. Tan x differentiation is 6 square x. F of x differentiation is f dash of x differentiating on both sides with respect to x. D by dx of f of x is equal to d by dx of tan x. F of x differentiation is f dash of x. Tan x differentiation is 6 square x. Okay, now exactly in the form of integration of ಇದನ್ನು ಬರೀಬೇಕು ಅಂತಿಲ್ಲ. ಇದು f of x, ಇದು f dash of x. ನಿಮಗೆ ಗೊತ್ತಾಗ್ತಾ ಹೋಗಿತ್ತು. It is f dash of x dx upon root f of x is equals to 2 root f of x.